fast model. It feels like sometimes everything we set up here, every project proposal we write, every EU project proposal we write, they should succeed, right? You should have basically 100% success rate for all the projects and stuff like that, which means you set them up in a specific way, right? And it's not this, let's try it out, fail, and then move on if it doesn't work, basically. So I don't know. Perhaps it's a bit of a European thing, actually.
Don't you think it's more American? I'm not sure. But
I'm not sure either. I think
Americans are even worse in failing fast. But I'm not sure. Silicon Valley is good
Silicon Valley is good at it.
Yes.
And that's probably I only see Silicon Valley in Boston, so it's, my view of the US is super skewed.
But the POC thing, I have a hypothesis that it is to some degree a Swedish invention to go this far on the POC and demoing. And I tell you that because I'm working in a consortium with several different niche experts that we together have a frame agreement with Scania.
Yeah.
And one of the companies are Italian.
Right.
And they are working on these topics, big data, data processing, AI, yada, yada, yada. Working with NL, a big Italian utility as a contrast, right?
Yeah.
And then Alberto is like, in his cool Italian voice, I can't do it. What's with all the POCs in Sweden?
Right.
So when he says that, I kind of pick up on that. Is that a trend?
Perhaps. I'm not sure. But perhaps we should start talking about MVPs rather than POCs or something like that. Just to put in context that, it's something that at least should have a further life if we get somewhere. It's, I don't know.
No, I'm not 100% sure about that either. I think that there is a value with POCs as well.
To show that something is possible.
And to be able to fail fast.
Yeah.
If you force everything to be MVP that actually is connected to the proper, production system, it will be really slow.
Yeah.
So I think there needs to be a balance.
But I think if you have a venture cap approach where you basically say everything we do has, start capital, seeding capital, stage 2 capital, like that, then basically the most important thing is that you consider things differently. The AI model, as we know, the data scientist piece, Lal has this beautiful picture he loves to show. We know Lal together. The model is 10% of the production problem, right? So
absolutely.
So it forces you to look at the whole consideration. But then you need to have the other steering that basically it's okay to fail. Because if you're really honest, in a traditional enterprise, you build and break careers on what works and doesn't work. So you're not sort of allowed to fail. So you need to build that all the way into the steering model. So I agree with you that you need to be able to experiment and POC and all that. But I think the pain of not having considered the whole topic of going to production is worse, in my opinion. So I prefer the MVP evolution. Call it evolutionary MVP or something like that. Let's do something like lean startup. How fast can we try something as an hypothesis and then understand if we're going to kill it, pivot, or improve it?
I think the three-step like rocket that we had at least at Peltorion was first you do like a POC, then you do a pilot, and the pilot actually is connected to the production system, and they can do a proper evaluation of it, but not having it fully productionized because that's a lot of work to do that. But then if it actually do pass the pilot stage, you do start working with the production version of it. But so many people, I think, underestimate the amount of work needed to actually properly integrate to a fully productionized system. It's a huge amount of work.
But let me throw a curveball on the POC, because I have seen a lot of POCs, which in my opinion is not commercial POCs. They are purely technical POCs.
But that's another thing. That's like wrong POCs.
That's the wrong POC.
It's not a problem with the POC. It's a problem of what kind of POC you choose to develop, right?
I think maybe the POC is not even a bad idea then, as long as it's there to prove a metric that is a business metric.
Yes.
Versus just I could connect these two things so I could get machine learning to work.
Agreed. I agree. Sounds good. Awesome. It's a pleasure and honor to have you here, Daniel Gillblad. We know each other for some time, and I think you're basically the go-to guy, I think, for a lot of journalists as soon as some AI problem comes up, and I know you
could be
one of the top, I think, people in Sweden when it comes to AI. So it's great to have you here on the season finale that we have for this podcast for this spring.
It's great to be here. Thank you.
Yeah, awesome. With that, perhaps Daniel, you can just start to describe a bit briefly. Who are Daniel Gillblad, and how would you describe your background?
Right. Yeah. I started out as a researcher really late 90s. I started doing my PhD and so on, and work at the Swedish Institute of Computer Science with something I thought was incredibly cool at the time, but no one really was all that interested in, which was machine learning. And
this is 99, 98, or
99 was the year where, when I was still a student, but I got hired at. It was called SIX, the Swedish Institute of Computer Science, and I got hired
at
there.
KTH at that time.
I was at KTH at that time. But there was Anders Landsner, professor at KTH, was both at SIX and at KTH, and he sort of brought me in and he put me at SIX. Yeah. And there I stayed for quite some time, even though I have been part-time at KTH, I've been working for some companies and so on through different kinds of contracts and stuff like that, but I was with SIX for 20 years.
That's impressive for sure.
Is SIX now part of RISE? Or how does
SIX is part of RISE
This
nowadays.
is part of RISE.
Yeah.
But can you find SIX inside RISE, or has it been broken?
Now
RISE is a new animal.
Yeah. It was sort of reorganized the last couple of years, and what used to be Swedish Institute of Computer Science is sort of intact, but it's in several different departments, basically, and stuff was moved around a little bit and so on, which is partly good because it had grown organically for a long time, and perhaps it was time to do a little bit of restructuring, but also a little bit, in some senses, sad, because one of the cool things about SIX was that within computer science and AI and so on, it wasn't that big, but you had people from expert systems, from logic, from compilers, from complex systems, from constraint programming, optimization, integer programming. You always had someone to ask, right, about the most esoteric kind of questions that you had.
That's a cool place.
It was very cool, yeah. It was great. It was super cool.
Yeah, and it stood for the Swedish Institute of Computer Science at that time?
Yeah.
But later it was it RISE AI? Was that basically?
Yeah, that was sort of what it merged into, what I led for some time then.
Yeah,
but and for people, there are some almost household topics, not household topics, that SIX was focused on and working on.
Yeah, there were a few things that
used to put a position what SIX was doing.
So SIX was, but you have to put. I started out in the neural networks and robust computation laboratory, but we
in 99 was it the neural network?
It was still the neural network.
That's impressive.
That's impressive.
Isn't it?
That's
but then,
AI winter right there.
Yeah, and we soon realized that no one cared about neural networks, so we had to switch our name. And became something like, what was it? Adaptive robust computation or something like that.
Whatever.
Whatever.
Now it would have been crash hot.
Yeah, but no one really cared in the beginning of the 2000s that much about neural networks, right? It wasn't really a big thing.
No, absolutely not.
It's but we still did backprop, and then we moved on to what everyone else also moved into a little bit. Statistical machine learning and graphical models and mixture models and support vector machines and all that kind of stuff, basically. But yeah.
And you started your PhD as well at that time, right?
Yeah, at KTH, yeah. And I did it in more statistical machine learning, actually.
If you were to try to describe your PhD topic in understandable way, how would you describe it?
To create a framework for structurally learning combinations of mixtures and graphs, basically.
Oh.
And of course, you can do that in many ways. You can put up a graph, and you can put in an unobserved variable that sort of creates the same thing. But our goal was a little bit to create some kind of combination of first having mixtures, or the other way around, and then having a graph, and then having a mixture, and so on, so that you could actually build these basically some product structures of probabilities. different ways of factorizing things.
And where are the typical use cases where this is of value, to solve these type of problems?
I mean, by that time, we weren't all that great in putting together really, really large-scale models. So it's really different today, basically. But for any kind of statistical inference and so on, so what you could do a little bit better was, of course, to encode some kind of knowledge and so on into these systems. So, and that was actually one of the things that we spent quite a lot of time on. This was quite a long time ago, but we were tasked by the Swedish Defense Agency to build. We had a project to build a general diagnostic tool for people out in the field that should be used for tanks and perhaps people, and I don't know, anything that in the field need conscripts to find out what's the problem, basically. So you don't have, super experts out in the field, and you can't really train them.
Root cause analysis?
Yeah, that kind of thing. And what's wrong with my tank, or what's wrong with this person, or something like that. And we quickly realized that, we should do this with neural networks, we should do this with graphical models, we should learn everything from data. And then we realized they have absolutely no data points for some diseases and for some faults and stuff like that. So you needed to start to encode some kind of knowledge into this kind of system, basically. So
it's a more rule-based approach.
Yeah. So we sort of did it in a Bayesian way, sort of.
You did Bayesian.
Yeah. So basically, we sort of structured everything into like, we created something that we called prototypes. So distilled knowledge. This is a typical expression of a disease or a fault that experts can set up, and then you use that essentially in a model as a prior for the data that you're looking at, and then you calculate a posterior that you use to guide people through the diagnostic process and stuff like that.
And we use the word now statistical machine learning.
Yeah.
Help me out, who is not on the same level as you guys. What do we mean with statistical machine learning, and how can we categorize that towards deep learning or whatever? What is it?
Yeah, that's right. I mean, in a sense, everything is statistics anyway, right? So, but it's
damn lies.
Yeah, but more about models that express some kind of distribution over data, and that you then can, for example, calculate conditional probabilities or something like that. And given that we know these things, what is the probability distribution over another variable that is part of this whole data set? What is the probability distribution? And then we can make decision and classification predictions and stuff like that based on that. So it's
Would you call it like a sub area? Like, is this a clear sub area within machine learning, like statistical machine learning, or how do you frame it?
I think so. I mean, it's a big difference to I'm not sure if you mean Bayesian neural networks or proper Bayesian networks.
Proper Bayesian networks. We were actually doing proper Bayesian networks.
Because that's so many people today is so focused on deep learning and neural networks. So when we say Bayesian networks, I think Bayesian neural networks, which is very different. So traditional Bayesian Bayesian networks, not Bayesian neural networks. They actually use proper probability theory to calculate everything, and conditional probability tables that they have for everything. And there is no parameters that you try to tune with backprop in any way. But today everything is backprop and neural networks.
But this is the evolution, right? We get more data, more cream, more power, more knowledgeable about the deep learning ways. So the methods change. Evolve.
And it's not like this more, let's call them statistically stringent stuff is not useful. It's useful for different purposes, right?
Yes.
If you want to, for example, encode some kinds of knowledge and stuff like that, they might be more useful. If you want to work with, let's call it, uncertainties in a very deliberate and manageable ways, they're super useful, basically. And we were talking just before here about this corona case and calculating spread of disease and stuff like that. So that very quickly becomes this kind of problem, basically. So if you've met a person with a certain probability of having COVID-19 during a certain stage, then you have a conditional probability of having it yourself, and then you have this large graph of people with connections between people who have met, and you need to propagate these probabilities basically to find out what is the marginal probability number?
So back to the core topic of tools fit for the purpose.
Yeah.
And this goes really much into machine learning and what type of data.
I basically did the PhD at the same time as you did, and I actually did also work with proper Bayesian networks quite a lot, and I was really, infatuated with them because it's so beautiful from a mathematical point of view. I think they can't really scale. That's a big problem. But they're beautiful.
They're very nice. They're super nice.
I wish I could follow you down in this journey of beautiful algorithms. I'm not really there yet. I'm trying.
Yeah, but I mean, mid-2000s, things started to change, right? More traditional neural networks and stuff like that really started gaining attention again.
Why the shift, or why the evolution? Was it? Can you pinpoint it? Was it more power?
You can. I shouldn't say.
It was a few different things, right? I think it's difficult to pinpoint. I mean, we can always simplify and say that it was, like we always say, when we go out and speak, we say access to more data, access to computational power and stuff like that. But it was also a little bit of a movement, right? The timing was just right to start to look into building deeper neural network structures. The timing was sort of right, and it's also a combination of all kinds of things. I mean, data, benchmarks was super important, right? Yeah. To have these benchmarks that you could actually work.
I think the AlexNet was still a big jump, but it was a gradual change, right?
It was
stuff that happened that built up together to a big change.
Yeah. It took a few years there, basically. And when you say that the first workshop of deep learning was at NIPS in 2006 or something like that, right? It was quite a long time ago.
But has it something to do with when something gets the attention? I mean, like we can talk about the hype cycle or whatever, but all of a sudden, like big brains are starting to shift their attention to something else, or slightly, deep neural networks, for instance. And then, of course, the data and all that is important, and the power of the computers. But isn't it the brain power is shifting their attention and focus into something, and then stuff happen?
Yeah. I mean, in a sense, I think that's definitely part of it. Yeah.
It's also the power of it. I mean, AlexNet could improve it 30 percentage points or something on ImageNet.
Yeah,
and then all the traditional approaches in machine learning was basically thrown out. So after that point, and this kind of really big, what do you call it? Step change in performance that you suddenly got.
Yeah. And wasn't that pretty important, right? Just the publicity of that big steps change. Yeah. I mean, that changed a lot.
It's like flies to honey, right?
Yeah. But ImageNet itself was pretty important. Otherwise, it would have been difficult to even try out these things and find a good use.
So there are several things. It's the power of the computers. It's interesting showcase, the AlexNet.
I mean, the use data set that ImageNet was, if they hadn't spent all these millions of dollars to produce that,
it
became a showcase.
It wouldn't have happened, at least not as soon as it
did. That
accelerated.
That showcase accelerated the whole movement.
And access to that kind of problem and benchmark and data that you could actually test this on, it made a huge difference, I think.
So many factors that is in interplay in order to get the whole movement to accelerate. That's an interesting...
I think so. And it wasn't like...
How can we replicate that?
It wasn't like people hadn't been thinking about building deeper neural network structures, right? The whole thing about let's just go to one hidden layer because it can represent everything, that was always a little bit of a cop-out, right? It's, we can't get anything else to converge anyway, so let's just say that's enough. At least sometimes it felt like that. But it did change. Yeah.
But let's get back a bit to your background as well. So you did your PhD, and let me ask you the stupid question, which I know the answer to before because I can think the same. But after your PhD, do you ever feel that you had direct use for the work you did at that time later?
No. I mean, the tools that we built and the knowledge and so on. You can pick from it. But I think that's also a good lesson, right? I mean, AI is quite a big toolbox. Yeah. If you learn a lot.
I think doing a PhD, it's more about, you learn to become a scientist more than you actually learn a specific skill in some small area, which you usually focus on.
Exactly.
It's like a math professor once told me, you don't learn math because you have use for it. You learn math because you want to show that you can do it.
Exactly. Yeah.
And that process, you become like a certified scientist in some way, right?
Yeah.
It's more that.
Exactly. But it's also, I got a very good advice during my PhD studies. Basically, someone said, a PhD being done? No. A PhD is something that you feel like you've moved on from, basically, and then you're done. It's not,
That's a good way of putting it.
And then I realized, perhaps I'm done.
But I need to confess, I have this starting to get an itch very late. I'm so impressed. I'm starstruck with all you PhDs. So I'm thinking about, from my end of, how, can that be done? Later in life,
yeah, of course.
A profession, can you combine it?
Yes.
I'm talking from a very personal level now. That I've been toying with these ideas.
You have to spend a lot of time for like 5 years, or spread it out. If you do it like part time, it will take a lot of time.
Well, and this is the core problem, right? So how do I combine it with the professional life? Is it doable?
I think that's tough, and it's also.
Then you can be like a what do you call it? Låtsasprofessor. Bill Gates is the professor of everything,
He's more an honorary
or adjunct or whatever.
Yeah, but I don't. Yeah, I don't know. I can't give any good advice here. I don't know what you think, Anders, but it's I think if you have the interest and you can make it work. Absolutely, but it might also and it might just end up a really serious guilty conscience. Always feeling when you have free time, I should have worked on. Do you know what?
And I have that with my family already, so I don't know.
So and if you just want to make money, you should not do a PhD.
No,
there are better ways to make money.
It's more an ego thing
than that.
Yeah,
but if you have other interests, you really want to develop your skills, etc., then it could be a good idea.
Yeah,
I think so.
Yeah, absolutely. Yeah.
Cool. And the thing is, you worked so long then in 6, but that means that you started at 6 when you did a PhD, right?
Before I did my PhD. I was actually hired before I did my PhD. Yeah.
Oh, yeah.
Yeah. So it was quite some time.
Cool. And can you just describe a bit the 20 years at 6? What did you start with? How did it evolve? What were the steps?
Yeah. So we started with a little bit neural networks, and that kind of machine learning quickly morphed into these kind of more statistical models that we talked about now and so on. And then also super quickly into whatever kinds of applications that we can put these things to use in, basically. And it was driven both by the fact that, of course, we are a research institute. We should actually try to see, how can we get this out into industry and so on. But also the fact that, when you apply for funding, at least when you were applying for funding and so on, you didn't really have a lot of open calls for things that fit AI and machine learning and stuff like that perfectly. You had to fit them into, something else, right?
Right.
So, we were working for a very long time with machine learning for network management and that kind of stuff, together with Ericsson, and then into cloud management and diagnostics for cars, for trucks at Scania, for, all these kinds of things, basically. But
so machine learning research applied to a problem.
Yeah. Because that's where the funding actually was, basically. It was in these applications of these things, basically, to a very large degree.
Do you think that's a good or bad thing, that funding goes to a more applied area of AI? Or, I guess there is a need for both, like basic research and applied, right?
There is, but in a sense, it's not. In the very general sense, it's not too bad, I think, because, machine learning is, of course, you can prove some basic bounds and stuff like that of algorithms and convergence proofs and stuff like that, but at the end of the day, we want to use it to build something, right? It's empirical at the end of the day. We want to try it on a problem and see if it actually works in practice on a real data set, on a real problem, right? So, of course, it needs to be applied somewhere, right? It's
but I get your angle, and my father is a doctor, and he always pushes hard. He both medical doctor and PhD. It's like we need basic research. He was at Fysiologen in Gothenburg.
Yeah.
Because this whole thing that real innovation sometimes needs to be bigger or needs to look at things that is 30 years ahead.
Yeah. But there's also but you can also divide it a little bit on, I guess, timescales and what it's driven by. Is it solely driven by business interest, or is it driven by curiosity? It can still be applied and non-applied, and and also, should we expect results within a year or two, or should we expect within 5 years, and so on? I mean, I think you can work with both applied stuff and basic stuff on actually several different time scales, even though basic research, of course, takes longer time to maturity and stuff like that. So I guess there are a few different perspectives.
But I think that's the right answer, because we even talked about that from how you build products last week, that we need our time horizons.
Yeah.
Short term, mid term, long term. I mean, like we concluded 3 time horizons is probably needed.
Yeah.
And then, let's call it basic research. Actually, it's just about the 3rd time horizon. Maybe that's the point.
To some degree in machine learning and AI, perhaps, at least to some degree, yeah.
Let me break off, what I said, we shouldn't do, but to another topic. But I just want to have a quick answer to this. Let's not dive too deeply.
I love when you are screwing up and not me.
But since you're speaking about this, so research can be done in a basic or more applied manner, and then you have results that you want to be able to see potentially in a short term or long term. And then you have research being done in industry, or you have research being done in academia.
Yeah.
And I struggle a lot, at Spotify at least, to have a proper research team there, and we finally got it. But it's sometimes really hard to move from just a few months of horizon to years, or even 5 years is possible, more or less.
Yeah.
Do you think that research in the future should be done mainly in academia, or should it be done more in industry, or what should the balance there between be?
Oh, I think it definitely. I mean, this is pretty difficult, right? Because of course it needs to be done in academia. Of course it needs to be done in industry. I mean, I think in Sweden it should be even done more in industry than it's done today, basically. Yeah. But if you go to conferences and stuff like that nowadays, there's a lot of Google there.
Yes.
So what's the balance?
Google, Microsoft, Facebook.
Exactly.
But it's the interesting. It's the real. Now we're back into the AI divide. Some people have figured this out, that in order to stay ahead of the game, they are so far ahead of the game. Yeah. They are actually doing the basic research for us as well.
Yes, they are. And they're sort of driving the agenda.
Yeah, but the whole OpenAI and DeepMind, I mean, they are doing basic research.
It's fantastic stuff, right? But it sort of indicates that if you want to catch up in the game, the normal companies needs to do needs to get into an R&D topic. I think that's to balance this out.
In a sense, so but it's not super easy to be a more traditional company, perhaps, and then just switch to being a Google or a Facebook or Baidu or OpenAI or something like that. It's not super easy.
But perhaps you don't need to go that long. I mean, you don't have to build another DeepMind 100%. No. But at least increase the horizon that we spoke of,
Yeah.
But I've been to 2 companies now where actually R&D is an ingrained part of those companies. Vattenfall has a very solid R&D area, and so does Scania.
Yeah.
So R&D is very closely connected to, of course, now the truck development, and I think that is something that makes them successful. Ericsson,
yes, absolutely.
Ericsson is hardcore R&D.
AstraZeneca,
right?
Very hardcore R&D.
But sometimes it's hard. If you take Microsoft as an example, I mean, they have an awesome, I think, research department. And then I think they are getting better in product as well. But traditionally, at least, I think they had a really hard time converting the research into a product.
Yes, super difficult, I think. Yes. I think they were really far apart from each other, basically, the product department and the research. At least it felt like it.
Yes, I think so too.
But not in Ericsson.
I'm not sure. I mean, don't they do a lot of no, I shouldn't say that. But I mean, in some way,
I have some insight, and even Scania have some insight, and I think Ericsson talked about the PLCM process, the whole process, right? And I've been certifying product managers in Ericsson in a previous life, and then where is R&D fitting into the the life cycle, from innovation to end of life of a radio base station, as an example. 4G, 5G, and all that, 6G.
Yeah, 6G is coming up, I guess. So
It is. They're working on it.
In Finland, they already have it, they say. But
yeah, they started a long time ago saying they're working on 6G.
Saying they're working with it, yes. Yeah, okay. But let's get back on track a bit here. And the research in industry, if I were to summarize what you said, I think we need to at least step up a bit there and try to have Swedish companies do a bit more research, right?
Yeah, I think that would be a very, very good complement right now to what we have, basically, and to have a little bit more open doors between academia and industry and so on, and get a little bit more movement. I mean, it's there to some degree, right? But not quite as it should be. Yeah. I mean, I would really like to have a Swedish DeepMind, right? It would be super cool.
Super cool.
But
or an vision, right?
Yeah.
Swedish DeepMind.
But it's not easy to get that. So.
But then you need to. I mean, like that's now we need to park the topic. But that's like a super interesting topic to pick apart ingredients to make that work.
Yeah.
Because I think you can, to some degree, you can distill what this DeepMind construct all about, right? What do they do? Like that's an interesting topic, but let's park it.
Yeah.
But Peltarion has a Swedish DeepMind, so it's good.
Yeah.
Okay, sorry.
Boom. I love it.
Let's move back a bit. Okay, so you worked 20 years in 6, and can you just describe a bit? You did your PhD there as well.
I was part-time at KTH as well during some, quite a few years basically. But then I was back at 6 again, and then also doing not only leading the. I took over and created a research lab in the 2010s, somewhere beginning there. That I managed for quite some time, and then did a few other things on the side. Worked a little bit for companies, both with strategy and did product development and stuff like that. And that was super fun because it gives you a little bit of grounding, right? It gives you, where does all the stuff that we do actually put in? Where does it work in context, both on a strategic level and how does it actually work to put these things out into real use? And that was super fun. And then these last few years, I started gliding over more and more towards, trying to build a few initiatives in Sweden. And I started working more and more with AI Sweden a couple of last years. And then, since January, I'm 100% at AI Sweden, basically.
Well, let's go to AI Sweden very shortly.
Yeah.
But I think we mentioned RISE a number of times and 6 a number of times, but we really didn't describe, what RISE is.
Yeah.
Could you just try to describe, what is RISE and how many people are there? What do they do?
Yeah, it's very big now. It's my guess is, because it's been fluctuating around because there were some acquisitions and stuff like that, between 2,000 something and almost 3,000 people. And I couldn't tell you what the actual number is right now, but it's pretty big. It's quite a lot of people, but it's a lot of different institutes. It's not just so there were a few institutes called Swedish Institute of Computer Science, Victoria Institutet, and Interactive Institute, and so on. And all of these were sort of in the similar area, but now it's a lot broader. SP, Statens Provningsanstalt, and all of that.
I was going to say that as the to show the breadth. Statens Provningsanstalt is part of RISE.
Part of RISE, yeah. And that's a huge part of RISE, actually. It's very, very big. So 6 was all of a sudden a very small part of it. And it's, we were 100 people, perhaps 200 people closer to when it started to become integrated and so on. And so not a very big part.
And spread out all over Sweden, I guess.
Yeah. All over Sweden. All over Sweden.
What's the mission with RISE or vision of RISE? Do you know it?
I shouldn't be the one speaking on this right now.
We can skip it. It's fine.
but I guess we can talk about what we think a research institute should be for Sweden, right? Okay. And it's like. And I think RISE is there and still has some work to do in some areas. But of course, it needs to be a platform. This platform between academia and industry. I really think there's a room there, basically, for people who not necessarily that can be at least part-time, let's say, academics, But instead of having education as your other part, you have, well, let's build something that works. Let's push it out into industry. Let's build software, whatever it might be. Basically, I think there's quite a big room for that.
I'm not sure what the future is and all that, but I truly believe that the position is there for RISE, even to take more than they do today. I mean, like we have other initiatives coming up when we're starting different initiatives. AI Sweden is another example. I think to some degree, RISE is potentially very well positioned to do, to be the deep mind. I'm just putting it out there. Could it be, could you organize, I mean, like if you rethink the purpose of RISE, I'm just going crazy. Maybe not, maybe.
I think with something like DeepMind and stuff like that, I'm a very big proponent on actually starting. If you're going to build something like that, let's build something new. Let's not get stuck into
so then you rather do
old
it on the
structures
side
and stuff like that.
So not in the old structures.
Yeah.
Good point.
I mean, DeepMind is very long term for sure.
It is.
It's about AGI and stuff like that.
Yeah. But if you're going to set something very different up, then I would say actually, well, we could rethink that basically. We don't have to necessarily, the first thought having to be, let's see what kind of structure we can fit this into basically.
Okay.
Let's try.
Fair point.
Let's just think about what it actually should do, and then let's take it from there basically.
Cool, but now you're working 100% for AI Sweden.
I am, yeah.
And that's an awesome initiative. Can you just describe for people, what is AI Sweden and perhaps how they got started and what they do? Yeah,
so it was basically something that came out of Näringsdepartementet, like it's almost 3 years ago now, right? Isn't it? It's something like that at least.
2009. Or 18?
18, I think the decision came that we should do something around collecting AI and applied AI in Sweden.
This is Johan Harvard that we had on the show as well. Yes. I think that was part of...
Johan was here.
Yeah. And then it really got started in 2019. That's really when activities started to really spin up.
So just to clarify, we had Johan Harvard on this show, and he was one of the in Näringsdepartementet when this was starting to be cooked up.
Yeah, and also with the is it called infrastructure? And before it was digitalisering, I think. So never mind the political structures, but there were some proponents there for doing something in Sweden, basically, and AI Sweden is the outcome of that. So so there is government funding. It goes through this government agency that is called Vinnova, because that's a very clean way of doing it, and has long-term, ambitions. But I think it's actually quite kind of fun to work now within AI Sweden, because we have the mission to accelerate the use of course, useful AI in Sweden, whatever means necessary, basically. I've worked in several research centers and research institutes and stuff like that before, where you have a mission basically to say, let's do as much research for the money as we can. Let's get as much education out as we can. We can take a little bit of a step back and say that, is education the most important part? Okay, let's do education. If it's research, research it is. If it's applied research, then that's it. Is it sharing data and bringing out models? Okay, let's do that. So we have a relatively broad mission, so to speak, and we don't have this 100% connection to the means. And that's kind of nice, actually. It gives us a little bit of freedom.
Let's flip it. The higher mission is to accelerate AI, useful AI in Sweden.
Yeah. I'm adding this useful AI because I got the question, because accelerating AI in Sweden, you can do that by just building nonsense, right? But it's,
GPT-3.
We should
we invest in GPT-3 and go nuts.
Yeah.
My sharp question is actually, so what are the fundamental goals and metrics that you connect to that mission?
That's super difficult to set up, actually, and this is something that all of these kind of long-term projects, I wouldn't say struggle with, because we're pretty good at setting them up, but it's sometimes they have to be more qualitative than quantitative, so to speak, at least in the short term, because if our mission is to make sure that Sweden is more attractive to people within AI, how do you cut out that part, what we can contribute with, basically. We're part of a much larger system and things like that. So it's difficult to measure, of course.
Yeah, I get that. If I flip the question, this is going to be on a mission. You're going to feel interrogated now. I apologize.
That's fine. I'm used to that.
So if you flip it,
at least as long as it's long enough in the new role that you will have soon, then I'm fine.
Okay, we'll try not to do that.
But I was thinking more, because I think this is so valid. I think it's so right, and I think the fundamental mission, we need to accelerate AI, is great. Then we can debate for a long time what are the 5 or 10 topics that will accelerate the agenda. What I see, maybe we're doing some things, but I'm like, that is a lower order priority than many other things. So that to me is interesting, how to shape what is the top 5.
Yeah, and that's on me and my co-director Martin and so on. This kind of funding that we have now, how do we invest this properly?
How do we
that's really on us. It's we're working furiously to get everything out there, and it's a little bit, which is also quite a bit fun, because the more we try out things, the more we learn and we see what works and what doesn't work and so on. And by working with some of the government agencies and companies and stuff like that, we can also get a feel for, okay, they don't know that they need these things yet, but they're gonna need it. So let's try to prepare and be there when they actually get there, basically.
This is a timing topic, right? So right now, the top 5 things is this. In 2 years, it could be something else.
It could be something else, yeah. But I'm not at all against working on stuff that's strategic on a longer term, so to speak. It's would I like to be, for example, Sweden to be the center of attention within edge AI and decentralized AI and federated learning and stuff like that? Yeah, with actors like Ericsson and our industry and stuff like that, it sort of makes sense, right? I would love to work for that, but that's not a 2-year mission. That's a longer term mission, basically. So yeah, the timelines vary, but it's
I remember the initial planning that we had in AI Sweden, and they had this kind of effect logik.
Yes.
It's like a methodology to try to do the planning in different ways and try to have both qualitative and quantitative measures in short and long term. Is that still in use, or is it?
Yeah. It's still there in the background. It's still there in the background. Although that changes slower than we change our directions. So hopefully we can match and merge these.
I must say, I was impressed, how we tried to really find good measurable, quantities of how we can see that we do what the mission says we should do, so to speak. Yeah. But of course, it's super hard, and you need to be qualitative in some areas. Yeah. It's no other way, I guess.
Exactly. But of course, we want to deliver the best results we can. Basically, it's not a huge amount of basic resources, so to speak. But I think we've come up with a philosophy that sort of works. That is more of this: let's invest together when we can, and share it then to everyone, and that actually works. I mean, even better than I expected to start with. Actually, it's
and perhaps you should just speak about the progress of AI Sweden, because it's grown so much in just a few years, like 2 years.
Yeah, it's
in terms of number of companies and regions and everything.
Yeah.
Can you give some kind of
sure? I mean, just for example, so. I'm pretty surprised myself when we look back, basically, because we started working on this. Yeah, two and a half years ago or something like that, in all of these meetings and stuff like that. Felt very small. And so 2019, perhaps it was around 20 companies or something like that had signed up and so on. 1 year later, we were around 60-something partners. Now we're close to 110. So it's expanding relatively quickly, and it's not just a network, right? It's not that you just sign up to a mailing list or anything like that. I mean, you sign up to actually contribute with your own time, with financial resources and things like that. And hopefully, like Piltarian, you get something back.
Yeah.
But
and let me ask this super hard question then.
Yeah.
What's the USP, the unique selling point for companies to join AI Sweden? Why should any company become a partner in AI Sweden?
Because you can't do it yourself in Sweden. That's basically it.
You nailed it in a single, few words. That's annoying. Okay, so what can't you do yourself?
Yeah, you can't attract all the talent you need. You can't attract all the resources you need, all the knowledge, the know-how, the models, the data. You can't get to all of it necessarily. Some very, very big companies can stand very much on their own, like Ericsson, like AstraZeneca, and so on. But they still need this connection to the larger ecosystem for talent, for other input, for surprising collaborations and stuff like that. Because it's, what we see now, it's a lot of the stuff that's been done for example, public healthcare and so on, comes a little bit from the automotive side and computer vision people that have worked on self-driving cars and stuff like that. And we need
techniques from one sector can be useful in other sectors.
Exactly. And that's a super difficult thing to do because it's something that we struggled with a lot, basically. Because when you're setting up these centers and stuff like that in many countries, you tend to do, we're going to do this and this and this part of AI. We're going to do neural architecture search and explainable AI or something that I know that you're working on. I chose a couple of topics that I thought you would like. And then we do healthcare and automotive and so on in separate different silos. We couldn't really get that to work because there weren't enough people in each different silo to work with and not enough expertise in every different area of AI. So we've tried to sort of flip it around, tried to start working with a number of strategic programs and initiatives and stuff like that, at least a few more from cross-sector and so on can join in and try to build something together and so on. Yeah. And I think some of these things are starting to happen. I mean, right now during the spring, just the super quick build of the Edge Lab, which is part of this program for edge learning and decentralized AI and so on. All of a sudden we have equipment for 20, 30, 40 million that everyone, at least partners can use and try out, right? That's pretty nice, and that people actually just put in the effort. It's really, really cool.
And if we phrase it in another way, perhaps, we are a rather small country in Sweden. We don't have, super huge budget from the government. We don't have super big companies. We have surprisingly good, I think, examples of unicorns that we built in Sweden. Yeah, and we have some really strong other companies like IKEA or Ericsson or etc. Yeah. So we are surprisingly good still in Sweden, right?
Yeah,
compared to a lot of other countries.
I think so. In a sense, yeah. And I don't know if this is true, but I do get the feeling that we have quite a lot of quite different industries that are relatively mature and could really be a player. I mean, we have fashion and retail and IKEA and H&M, and we have Volvo and Scania and Volvo Trucks and all of these, automotive transport. We have lots of production and mining and all of that stuff, and everything is relatively sophisticated, right? Yes. So, I mean, in a sense, it's like a colleague of mine, Mats, used to say, we're a superpower in being the place where we have lots of different areas, lots of different resources.
Yeah, so shout out to Mats Nordlund. Yeah. He usually speaks about how awesome Sweden is.
Yeah,
he can phrase it really well.
And I know, I mean, he really doesn't want me to say that Sweden is a small country because that would annoy him. So I'm trying to avoid saying that.
Yeah, no, I mean, it's really true. But still, we have a problem of fragmentation in some way.
Yeah, definitely.
So for one, companies themselves try to solve it themselves, and it's super hard. We have a large number of initiatives happening, both from government, but also from other, like Research Institute and WASP and whatnot, and Vinnova certainly, and so many other things.
Yeah, definitely.
Some people say that Sweden is really good in collaboration, and I think potentially we have been but we need something.
We need something, and we need something more. We need to. I mean, we're getting there. I think we're tying up a lot of loose ends now. At least I feel like we're in a better place within the AI sphere than a couple of years ago, at least, which feels pretty great. But sometimes also, and this is just a nagging feeling I have, that we're good at talking about that we're collaborating, and we're good at sitting in meetings and talking about that we're collaborating, and by sitting in these meetings we have collaborated. But what have we actually done together?
What has been co-created?
Yeah.
What has been co-created? What has been the output of the collaboration?
Yeah.
That's what you mean.
Yeah. So sometimes of course we have lots of good collaborations where there's been great outcomes, basically. But I just have this nagging feeling that perhaps we should be even better at delivering stuff from these collaborations and not just.
So one output of AI Sweden is, I guess, the Nokia metaphor, connecting people.
Yeah,
right?
Exactly. Yeah.
But they also do some other stuff, like...
That's the Hyperite connection. Hyperite is trying to steal Nokia's tagline. I think you should start using it, and maybe your Hyperite logo needs to change with a little bit of a Nokia style. I don't know.
Right.
The event business is connecting people nowadays.
We are actually using it, but it cannot be official because then it's a legal problem.
Oh, I see. But Nokia isn't using that anymore, right?
No.
Should be.
But you do a lot of other stuff in AI Sweden as well, Data Factory, Age Lab, etc. Perhaps you can just quickly speak a bit about what are these initiatives and what are they trying to help with?
We can take a few of them, basically, because I think that, you mentioned Edge Lab and this collaboration around moving AI to the edge and actually trying out things in practice on real hardware and stuff like that and see how it works, because it's becoming super obvious to large parts of industry that, I mean, they're just going to have to do it, right? The car companies are realizing that moving data from China, perhaps not going to happen, so these cross-silo, but also these cross-device problems and so on, they're going to be present, right? So we're going to have to do something there. So these things are really cool, but I think that the natural language processing and understanding stuff is also something that is super important and that we get further on with in Sweden. Not only because it's critical to have Swedish language models, right, to actually build upon, and it's good Swedish language models so that we can actually build stuff in the Swedish language. But also the fact that a lot of the development that happens within AI right now is, at least partly connected to some things that are driven by language models and things like that.
It's like we've seen, when I worked in Peltori, we could see so many companies said they had data, but in reality, when you try to ask them, they didn't really have it. But text, they do.
They do have that, and it's super important. Yes. And it's, and wasn't that quite a big shift? Because for a long time, when we talked about deep learning and these very, very capable models and stuff like that, it was typically computer vision that was the space that you could really, really, really do something in. Tabular data and text, not. But I guess attention is all you need, all right?
Moving to the transformer side.
It changed everything, right?
It is. It's taking over the AI world
in
many ways.
Leading question, when transformers goes beyond text to other areas, do you see it happening? We had Robert.
I think we can see it happening right now. We
sure.
can see transformers moving into computer vision as well, right?
No, and because very concretely, new opportunities, new deep tech with transformers used in not text and vision, but for hardcore business use.
Yeah,
I think that when you understand the power of the transformer, the power of attention, and then you start applying it, you realize how you can take that knowledge of how it works here, but apply it to a completely different problem. I think that will blow the lid off that the performance. That's what Robert is telling us. I truly believe it. I think transformers is sort of bigger than we understand in terms of it is a quantum leap in some ways, isn't it? I don't know the stuff, so that's what I'm asking.
Should we go to that topic? I think it's potentially a topic in itself. The whole self-supervised approach, I think.
I was thinking about that. That's absolutely critical, I think. The whole self-supervision part is absolutely essential.
But let's park it, because I want you to pitch me now from AI Sweden.
Yeah.
Okay, so I'm putting a case in front of you. I'm sitting on some really cool tech and ideas around smart manufacturing and basically doing 5G all the way into to cloud. So basically sitting on a chain of thinking like, ooh, this is something we really want to test out or try out.
Yeah.
And I'm in the position where we're going to do it ourselves. We have the 5G router from Sierra Wireless.
Mm-hmm.
We're going to hook it up with some Ericsson stuff, and then we're going to try it like this.
Yeah.
So why shouldn't I do it myself? And why should I, how can I utilize AI Sweden's resources? Or how could I, because I'm not part of AI Sweden today, but maybe I should be.
Yeah. No, I think that, in all honesty, I think that's a decision that if you're a company and you really want to protect something that you're doing and so on, perhaps we're not necessarily the venue to collaborate within them, because there needs to be for things to happen together, for us to actually invest together, because we don't have that huge AI research and application and innovation investments in Sweden. We have to sort of solve it ourselves. So my pitch would basically be then, so take a step back, look at what is business critical to what you're trying to do, basically. What is more basic problems that you could perhaps benefit by collaborating with other people for developing?
What's your IP? What is your competitive edge? And what is more general purpose?
Exactly. And then bring the general purpose stuff into AI Sweden. I can guarantee you that there are other people that are interested. If you have the problems, other people have the problems as well. And then work on it together, basically. You will gain resources. You will not have to build up all infrastructure, knowledge, and stuff like that again, basically. So I think that's sort of the basic pitch if you're a company that's thinking about trying to do something super specific, basically. Just take a step back. So what
is my core IP?
What's your core IP? What needs to stay with you? What should you experiment with together with other people, other researchers, and so on, to actually learn faster?
Perfect answer.
But speaking about that, because we've been saying so many times that Sweden is good in collaborating, and AI Sweden can be a coordinator and really making that happen potentially. And you have human resources that can also know, we have all these partners, you should probably speak to that one. Yeah. And that's good.
Yeah.
But still, if you take another example, you spoke about the NLP Lab, for example, the Swedish language models for Swedish authorities project that we have. And it's super important, of course, as you say, we need to be able to understand and use AI for the Swedish text and Swedish language the best way can, and that is obviously very easy to understand and really useful thing.
It's an easy pitch. I use it a lot because it's such an easy pitch.
But also in a project like that, we have RISE part of it, AI Sweden part of it, Batarian part of it, and a lot of authorities like Skatteverket and Arbetsförmedlingen and others. But it's not easy to collaborate still within a project like this.
No, it's not.
And then we want to have the results coming from this project to be as accessible and useful as possible for other companies. And what I'm thinking about now, just to explain what I am trying to get at, is how should we really make the results of a project like this available? Partly internally, but mainly externally. When the project is finished, so we maximize the usefulness for it.
Exactly. And this is part of a bigger discussion, I think, actually, because it's. What we're trying to solve now, when we have this intention, is basically saying that we want to go beyond just publishing some code somewhere at GitHub.
You can't publish just the research paper.
You can, and you could publish just a research paper, but we want to go beyond that, right?
Yes.
You want to have an output. You want to have value. You want to have your library that becomes a Swedish NLP.
Exactly. Yeah, and it's more than that as well. I mean, we talked about ImageNet before, right? So, if we can develop benchmarks, those are super important. They will drive everything much further, basically. So we need to share those as well. Data sets, annotated data sets, all of that kind of stuff, best practices, and that's a huge challenge, right? And it's also, from the, let's say, storytelling side, I think that, research papers, it's great. I wouldn't say that most of the research papers within machine learning today is super difficult to read, but they're not super easy. And they don't provide a condensed version of what you need to know in many cases.
You're coming to the use case factory here, even.
Yeah.
Yes, that's one of the goals. But I mean, if you take, let's say that we publish a research paper, like we did for Federated Learning or something, and then Scania wants to make use of it.
Yeah.
Is the research paper sufficient for Scania to start making use of it, or no?
I can say no immediately.
Yeah. And that's a problem, right? I mean, we've had this problem for such a long time with getting started with stuff, and we still have it. I would say, I don't know what you think, Anders, but I still think we had pretty big reproducibility problem.
Yes, for sure.
It's,
So even within the academia.
Even within the academia.
But then even harder when it comes
to... and applying it.
Yes.
Because when you develop a research paper, you have a different kind of focus, right? You're not thinking about a wide range of applications. You're thinking about making something work on a specific type of problem very, very well, and so on.
To publish and all
that. Yeah. So it's part of the mechanism. It's fine. It's but it's a very particular mechanism, basically, and the gaps from going just from a research paper just to reproduce it is difficult, and then to apply it. Is a further step. And then it might not just be one paper, it might be many results that you might need to combine ideas from and things like that. And that here, I think, our field is not great at putting together these more, let's say, distilled views on methodologies and technologies and algorithms and stuff.
But let me put you two guys on the spot here. I think the NLP project within AI Sweden is one of the most useful, potentially easy selling pitches we have. I mean, like in one way, I think it's the poster child because it's so clear. Yeah. It's easy to understand, right? But now I flip it and I ask you, what is the dream scenario output? What's the usefulness? What's the value? What are you aiming at ultimately? If my wet dream came about, we would have produced this. What is it?
You want to start, or should I?
You start.
I'm getting right into your love pet discussion. But this is a great project. It's a great topic, but it's still difficult, right? But what can we get out of it? No. What do you want?
I mean, I think, we can take the exact stakeholders that we have in the project, like Arbetsförmedlingen och Skatteverket, and speak about the specific problems there. They're really
solve
concrete.
Their problems.
And that's, I think it could be an inspiration for, if they can do it. AI is such a GPT, a general purpose technology, that, if they can do it for this use case, it's surprisingly similar to so many other companies and organizations, not only in authorities, but also throughout the sector or industry, I would say. So perhaps the easiest way to describe it is just to name a couple of very concrete examples, what you can do with it.
Yeah.
And let's take Arbetsförmedlingen. I think that's everyone understand what they want to do, and match the seekers to the providers of jobs. And you connect, the job ads with the resumes that you have. And of course, you need to understand very, in detail, what are the resumes saying. And if you don't understand the Swedish language, good luck with that. Then you have to do it manually. So taking, and I think, the thing that we don't want to do is perhaps completely automate it, but rather to say, how can we have the humans not having to manually go through everything, because you can't sit in real time to match every job ad to every resume all the time. But you can have people helping out, trying to find, these are the top 100 recommendations, perhaps. If you sit as a person working in Arbetsförmedlingen and they have a certain person in front of you and you want to help them find a job and they try to describe, this is what I want to do, how do you find the job ads for that person? Well, you can either have all the knowledge in your head, saying these are the companies that you have, or you have a smart AI system that understands the Swedish language and say you simply type some query, some kind of description of this is the type of job I want to have, and then you can find job ads, even though it doesn't match really word by word, but it matches from a semantical point of view. That kind of tool would be awesome to have. So moving, to a more semantical understanding of the Swedish language and then putting that in the hand of the humans, I think it would be such an insane improvement in or augmentation of human capabilities that we have. And you can say the same for Skatteverket or someone that trying to they get some kind of requests from a legal point of view. Perhaps is this okay for me as a company to do this and that, and they have to go through a huge amount of data from some legal database that they have. As a human, either you have everything in your knowledge, in your head, which very few have, or you have a help with an AI system that you can type some kind of natural language question to it, and it can basically recommend, here are potential answers to your question. And then you have suddenly a significantly augmented human that can answer and handle, their mission and their tasks so much more efficiently that they never could without using AI.
And how would you frame the output of Dream from this initiative?
Well, if you take it from first of all, I completely agree with you. And I really also like the idea of a large part of AI is making actually computers and machines more human and human friendly.
Yes, exactly.
It's not the picture that a lot of people have, that they're monolithic solitary devices that should make decisions for us and so on. A huge part of AI is making them more human.
Yes.
And more human understandable, which is something I think we should get better and better at explaining, basically, so that people can approach these things in the right way. But apart from what you're saying, basically, I think also looking at the outcome as a national resource, basically. What can we bring out of this that we can then share again and again and again? Because that's sort of the mission that we have, basically. So what can we bring out from this?
Now this is goosebumps moment properly for me, because this is a little bit like if I sit with these kind of questions in Scania, some guy is going to nail me down and say, Henrik, what's the outcome of your initiative? What is the deliverable that is tangible when we are done, and what this is going to cost me, right?
Yeah.
So this resourcing, what is that? Is that, like papers and knowledge? Knowledge is resource to explain stuff.
Yeah, absolutely.
But it could be more, right? It could be a framework. It could be a
absolutely.
A TensorFlow, a shitload of this is the Swedish model. Blah, blah.
It can be a somewhat, in this case, a somewhat curated data set that we sort of trust and that we know. That we know at least part of the bias and all of that kind of stuff, that's super important as well. I mean, all data sets have bias, and as machine learners, we want bias in data because otherwise we don't have anything to learn, right? But
learning from Alex.
Not all biase is bad.
Exactly.
You need to have some bias, otherwise it's useless.
Exactly, otherwise it's just noise. And
yes.
Exactly.
But this is important, right? We said it, right? What was the inflection point that made neural networks grow? It was the AlexNet. So what was it? It was a huge data set. It was benchmarks.
Yes.
There was several things that made it into a reusable resource.
Yes. And we need to name all these things and share what we can here, basically. And I think we can't show it here, of course, but you made a great slide here. For the language project, basically, which contains a lot of these things and lots of these potentially shareable things. And I think what's sort of striking, especially when you come from research and so on, a little bit more perhaps, is that the papers themselves are just a very small part of it, aren't they?
Yeah, exactly.
The rest of the resources are way more important to actually accelerate stuff. So,
but it's because I like the way you are framing a vision, and that is super important, super needed. But someone said a vision without execution is hallucination.
I haven't heard. That's another T-shirt.
Vision, so I love the vision. What's
one.
the concrete output? What are you putting on the table? What resources library have you built? And having that without the vision is not as strong. But I think to also be really, really good in these projects, and this is something we can learn from business.
Yeah.
That I'm not going to invest any money if you don't show me the ROI. What's the ROI on your project?
Yeah. But you also have to be a little bit. I guess that you have to be a little bit open. I mean, you can in some of these projects that we run and that we've been part of, and especially applied research and stuff like that, you can sort of guess beforehand some of these things, but not all of them, right? Some of the learnings are a little bit surprising, like learnings about best practices and how to handle legal stuff, which is becoming a huge issue right now, basically, right?
It's more time-consuming than actually training the model itself.
Exactly.
But then that becomes another part of the resource. That also indicates this is a journey and an iterative evolution of how you define the goal and the deliverables. Yeah. But I think it's really healthy to have the vision, but not hallucination, right? What does it lead us? What path does it lead us down to channel our focus, our investment, our work?
Absolutely.
Awesome. Let's try to close off the AI Sweden topic a bit. And we've spoken a bit about what they do and try to connect people and provide resources and about data sets and computational resources and all these kind of things, and having all these projects that you work with. What's the next step? What's the future? What's happening in coming years in AI Sweden?
So basically now I would say a couple of things are really, really occupying my mind right now. First is basically now we have a solid ground to stand on. We have a good partner network. We bootstrap this super quickly and so on. Now we really
the regions, we have like 6 regions now.
Yeah, 6. We're in 6 places, right? We're in South, in Gothenburg, Örebro, which is that region will also be wider. Stockholm and Norrland is this little tiny region with a based in Luleå and so on. So we're Sweden is sort of all over Sweden right now, and with lots of partners and so on. So now we have a solid foundation, basically. Now it's up to how do we use it, basically. So I think that basically how can we invest in some really strategic core things together, where can we really come together and really work on research innovation together, basically, on an even larger scale.
Can you exemplify what that could be?
I think a couple of things that are coming together right now are the extension of the decentralized learning, federated learning, and edge AI. I think this is going to be a huge topic for so many companies and so on, and they're really showing that they're willing in investing in working together on this, which is super fun, basically. And also the other thing that's really up and running, and it's going to be, at least we can see sort of how we're going to do it. It's this whole, natural language processing, the text part, which is of course very quickly moving into more multimodal aspects and so on. So I don't see NLP just NLP for the next 2 or 3 years even. It's going to be multimodal really, really soon, right?
What do you mean? What do we mean multimodal when you say it's not NLP?
So it's not just a model or a machine learning model or other kind of model that models text itself, but it's in conjunction with, for example, sound and speech or video or images or something like that, or tabular data or whatever, basically. And I think that's also one of these very, very super big trends that are happening right now, right? We're really, truly going multimodal.
Could you please...
multitask, multilingual.
Exactly, everything.
Yes.
And federated at the same time. It's going to be super easy, yeah.
But let's go back to, let's nail down multimodal tabular. I think this is some of the stuff where we are doing stuff with NLP and it's moving out of its own text box, so to speak. Mm-hmm. And this has so many uses, I believe. But could we use, for the ones who's not completely into the lingo and all that, and me included, what do we mean with tabular and multimodal? What is this? Why are you like kids in a candy store when you mention those things? You're excited. You're excited, right?
What is the usefulness? Let me give a concrete example then as well. And one of the use cases in the language models project is for Folktandvården, the Swedish public dental service. And they want to basically predict if you should prescribe antibiotics or not. And then you can use patient journal text, the text that the medical doctor writes, about each patient to try to decide, should we prescribe antibiotics or not? And you may find, sufficient information from the journal text itself saying, you should prescribe it or not. But in some cases, it's not enough. In some cases, you need to know this is the age of the person, this is the gender of the person, this is the perhaps race or other things that you need to know about the person to make a better prediction of trying to understand if you should prescribe antibiotics or not. So that other type of data is basically tabular data. So if you combine, the tabular data that you have with more unstructured data like text, then we have a multimodal approach that use both the unstructured text and also tabular data to have a more holistic understanding of, for example, the patient in this case, and make a better prediction.
Because I think that example is nailing it, right? For the normal human beings who are not in the same world as you guys are on a daily basis, we have our old data warehouses and we have our numbers and we have that. This is BAAI, right? And here we have something new, fancy AI, and it's converging. Something is the ultimate.
But don't say BAAI combined. BAAI is not tabular. Tabular and BAAI is two different things, I would say.
But I was trying to simplify by saying we have structured data in a certain way, and we have unstructured or text data and stuff like that. And so maybe that's a better word: structured and unstructured data.
Yeah. Even though some people working with text would be a little bit annoyed saying that text is unstructured. There's a lot of structure in text.
A linguist would be
a linguist would kill me. I get it. But I think that's so when we say multimodal, and especially with tabular, it's the convergence of this sort of data warehouse or sort of tabular. It's not only number. It's not only
warehouse. I mean, warehouse is usually connected to BAAI a lot as well, right?
Yeah. I'm trying to simplify, but maybe I'm taking it too far.
But I think I like the ideas of actually broadening the scope of where we can actually build useful applications and so on. Because as you said, sometimes there's not enough information in the text alone, not in the tabular data alone, not in sound alone and stuff like that. But together, and if we actually can start working with them together, which is difficult, by the way, it's always been difficult. It opens up so many more new potential really, really cool applications that we can work on. And if you're a bit more of an AI geek, of course, this is, understanding language in itself just from text is difficult. You sometimes you would like to ground concepts using other kinds of data and so on. If you want a computer to interact with a person naturally, it's not just text, right? It's phrasing, context. Now we're looking at each other here right now, right, and reading small cues and things like that. So language and let's call it communication then between humans is so much more than just text and one mode of communication. So it has huge implications, I think.
Yeah, true.
And now I understand why you're like kids in the candy store. Multimodal is cool.
Yeah,
I mean everything is going
cool.
that. Yes. If you see what Facebook is publishing these days, and Google is also starting to move in, and so many others, it's going multimodal, multilingual, multitask.
Yes,
like having more and more generic models that you can train, and it actually benefits because you can avoid these kind of problems if you have a lack of data in a certain, for a certain task or a certain language or a certain type of modality.
Yeah,
by combining it, you overcome these kind of problems, and you have a more generic and I guess from a Lord of the Rings point of view, you have a single model to rule them all.
Yeah, one model to rule them all. Yeah,
but
I'm not sure I quite believe in that yet. But yeah, sure.
We're not there yet, for sure. But it's moving in that direction.
There is a potential now to go into one direction of this conversation, because what you're doing when you're starting combining the different things, are we moving more to AGI?
I mean, it's AGI.
Is that too far a leap?
I mean,
is this the baby step?
Well, first of all, it's a difficult topic to talk about because we have to talk a little bit about what is general intelligence. Then we are actually using the term in a number of different ways. Yeah. So if you're talking about, for example, humans, which are often hailed as the example
let's
of
say
AGI.
That we actually moved to this topic. I think we should move to AGI a bit and say that
That's the bridge then, right?
Yes, it's the bridge now.
So human intelligence is not superintelligence. We know that.
No, human is not general. But let's try to move into AGI a bit and think, Yeah. Okay. How would you describe, the movement to AGI? What does it mean? Is human level intelligence similar to general intelligence? Is the movement of multimodal, multilingual, multitask moving in that direction?
Yeah.
What's your thinking about AGI? It's a super broad and sorry for
yeah,
the fluffy
it's
question.
That was a fluffy question.
Let's just start somewhere and let's see where we end up, basically. But yeah, I do think that yes, these multimodal models, and let's say a lot of the structures and principles that we basically the whole field has been working on for the last 5 or 10 years and so on. I don't think anyone yet if can say how these would fit together to form a more general transferable intelligence. But I'm getting more and more confident that we're at least on track on finding some of the principles that can go into one of these machines, basically. We're sort of starting to understand some of these things that could potentially be part of these
and
things.
that's all I meant, right? So when we are cracking multimodal, it's one piece of a huge puzzle for AGI.
Yeah, it is. I mean, and we should also say that, we can perhaps build a more human-like intelligence, but as you said before as well, human intelligence is not super intelligence. And you can also discuss a little bit about how general is human intelligence.
Exactly.
Because we're very, very specifically tailored to how we observe and interact with the world, right? Yeah. And we're going to have to build and want to build intelligences for machines that see the world quite differently, right? So what is general intelligence and what is super intelligence is a different matter. But it's a little bit of a different
Let's just define it a bit. Super intelligence, being able to be smarter for some specific task than a human, like playing chess or multiplying two large numbers.
Yeah.
We've been.
If you're better than a human on a certain task, is that super intelligence, or is super intelligence inferring a broad reasoning and stuff like that as well? Or can you be super intelligent and narrow in the definition?
I think super intelligence. You can argue me on this, but for me, super intelligence is simply better than a human for some task.
Yeah. For a task,
yes.
not in general.
Yes.
So super intelligence and general intelligence is slightly going in different directions.
There's different things.
Yeah.
Thanks.
But I think a lot of people talk about more this super intelligence that move towards some point where the systems can learn to build themselves better and better and reach this point of they can actually develop themselves and so on and become.
I've heard that definition as well. Super intelligence.
And that's a different path, basically. So
super intelligence in that context is when you will lose control kind of storyline. Is that what you're talking about? Or when they evolve themselves beyond what you...
That's more singularity.
That's more singularity.
Okay, that's singularity. That's singularity.
And this is something that, because it happens, people ask, when will that happen? It's like, first of all, it's if. I think it might be possible, but but when? Yeah, we have no idea. We don't know the exact path, basically. So
so now, Daniel, when will the singularity
What's
happen?
your number? What's your
number? Number of years.
We have asked several. We have a betting list going on, more or less. Is it? Put the number down
for singularity.
Yeah.
Wow.
Impossible.
That's impossible.
No, but
absolutely.
But we will not not leave the question until we get a number.
Okay.
And it can be 500 years, 1,000 years.
Yeah,
I'm joking.
In 150 years. Yeah.
150.
What really?
What is your number, Anders? Right
9
now?
years.
9 years. You say 9 years right now.
So Ray Kurzweil says 9 years, or even 8.
And you love him.
No, I don't. He's been right, so many times before. But it depends a bit how you define singularity.
Exactly. It's a chicken and the egg, right? Because we first need to get the definition right, and then we can discuss it from
Yeah, and it's
a
fun,
little bit.
Yeah, and if we're talking about more the singularity, I don't know. It's random. I don't want to say 150 years either, because it's such a. When does an electronic component fail? I don't know. It's, it fails when it fails, right? I don't see the way forward exactly, so I can't tell. It could be 3 years, it could be 150.
But so many people think that Terminator when they hear singularity, and I do not mean the Terminator will happen in 9 years, if that's what you mean. So but so many people are.
Yeah, but I think,
Skynet.
yeah, and
Yes.
I think the problem is a little bit like when people have been asking me about the timeline for more general intelligence in some senses that we've been talking about, and it's like I can say in 10 years or 15 years. But I probably said that same thing 10 or 15 years ago.
Yes.
So what does that mean?
Exactly. It's always
It's always 15 years ahead. It's always, so what do we mean, basically? Yeah.
And
but it's fun. So
Yeah.
we have
Definition.
it's a bit of fun.
Yeah. But no, I can't see a direct route to the singularity, which means I wouldn't bet on anything, basically. That's basically it. Yeah.
Okay, so if we speak more about the vision that OpenAI and DeepMind and probably some number of Chinese companies that we don't know, like Alibaba, Tencent, or Baidu, and so on, probably also have these kind of initiatives.
Yeah.
Do you think that's a worthwhile thing to put so much money that they do in?
In a sense, yeah. You can discuss the approach and whether or not that's sustainable or not, basically. I mean, do we want to increase the parameter count and transformer models by 10 or 100 and, how far can we get? But...
because in some sense, if you see what DeepMind and OpenAI and others are doing, is basically scaling up the models.
Exactly.
Year, like a magnitude more.
Just magnitude bigger all the time, basically. So,
How big is the biggest data set now?
I think that actually, I think the biggest is a Chinese company now.
I think the biggest is Chinese.
GPT-3 is not the biggest.
No.
No,
I think the
it's
Chinese
old
stuff
school.
is
1.7 trillion.
yeah.
Trillion.
I think it's like, isn't it? Yeah, it's magnitudes larger. I think than GPT-3.
Yeah,
and GPT-3 was the biggest when it came, right?
I think it's 1.71 or something. So it's literally 10 times more
Then
than
it's
GPT-3.
10 times more.
In how many?
And that's a lot.
So someone screwed the Moore's law here somewhere. I mean, like, this is in how much time? In less than a year? Or in a year?
I don't know. So I don't know. GPT-3...
Maybe last year?
Yeah, something like that.
In 1 year, 10 times.
Yeah, but you also we also get to a point where we're catching up with how much we can do here, because if GPT-3 was roughly 300 GPU years or something like that, I don't remember the exact guesses. But I mean, if we're gonna do, I have no idea what the convergence times were on these Chinese models and stuff like that, and perhaps it's not 10 times as much resources and so on, but still. We're pushing the boundaries pretty soon, right? With what is actually even reasonably feasible to run.
And people, I think we should also be clear that GPT-3 is not a practical use today.
No,
right?
No, it's not.
We have so much. At some points in this podcast, we managed to get a GPT-3 joke in every time. I love it. It's always about me pushing him.
But would you agree, Daniel, because so many people are asking actually, can't we simply use GPT-3 for our, business use case that we have here? And I tried to explain, there are 10 other models that are so much smaller, so much better. You can fine-tune your own data. It's so much better. And
Exactly. So GPT-3 is super cool. It's really immensely cool.
2.6.
Yes. Yeah.
Is that the one?
What? Oh, I haven't heard about. No, billion is nothing. It should be trillion.
It should be trillion.
Yeah, this is not the one.
Anyway.
It's not a language model. I think it's a multimodal.
That's a multimodal model, I think. Yeah.
So,
but it's still a transformer model.
But,
yes.
You so I understand what we're talking about. When we say it's trillion, what it's been trained on? What is it?
175.
175 trillion.
Yeah. So exactly, it's 10 times exactly to GPT-3.
Yeah.
Exactly.
That's
10
a
times.
lot.
So they went out to get 10 times. And so what does that mean? So they've been scraping the net for 10 times. The model has been trained on 10 times more data.
It's a number of parameters in the model itself.
Yeah, and since they've gone multimodal, and when you move to the vision side and using transformers on that, the parameter count might increase quite drastically, basically.
And could you what do we mean? What is a parameter?
It's a number of neurons. I'm sorry to use that human term because it's not a proper neuron, but it's a number of weights, or what's the most understandable term to use?
Number of artificial connections, but number of weights, I think, is a.
So if you break it down and educate me, when you build a neural network, what is the parameter part of the network?
Yeah, so the parameter part are the things that you change in the model when you look at data, that you gradually change to get better and better at classifying or detect cats and dogs in an image or something like that. So you put something into a neural network, it goes into numbers like the values of pixels or values in a table or something like that. Then it goes through weights. You weigh each one of these things with a certain amount, multiply it with, and then you sum it up.
Grows with weights.
Yeah, the weights are the parameters.
The weights are so like you have classes and then you have weights.
Yeah.
Can you say it like that?
Yeah, your classes is on the output side. Weights are basically part of the specification of the model, basically.
So it's an insane number of weights.
Perhaps it is easy to use the brain as an example because it's so easy to understand. I mean, you get some signal in your eye.
Yeah.
That signal hits a number of neurons you have in your eye, and it moves forward in the rest of the brain, in the cortex, etc. And each of the time it actually causes some kind of spike or some kind of action to happen in that neuron. And a number of neurons that you have, we have billions in the brain as well, not trillions, but still, it's a lot. That is basically the way to do computation, I guess, in the brain. And we're trying to have a similar, but it's very, very different in artificial neural networks, since we use backprop, etc., which is not happening.
That's
in the brain.
not happening at all in the brain.
What's backprop in this case?
You basically take something on the, let's say you show a neural network and input an image or something like that, and then through all these ways, through all these parameters, you propagate these values. You get to the end, and there you can see, was I wrong or not, and how wrong was I? And then propagate this error back and try to assign how much each weight contributed to that error. And then you tune each parameter just a little bit in the right direction to be better next time. And that's this back propagation part, and that's
really nicely described.
Thank you. But I think this is important, right? Because in some ways we're all playing catch up with you guys, and you are playing catch up with the Chinese guys, apparently.
We're not going to catch these Chinese guys, not with any Swedish.
But
and I hope we don't build a Swedish GPT-3 or something.
So now...
Okay, well, why not? Well, if we were to do AGI in Sweden, yes, then we should do it. If we want to use AI for practical use cases to help the industry, we should not do in Swedish.
You build a multimodal.
You have other models like T5, etc., or so many other things that are
MT5.
Much smaller, and they are possible to fine-tune. They open source.
You can tune it for different use cases.
You can do it on a single GPU. You don't need thousands of GPUs to train it. It's feasible, possible, practical, and even much more accurate than GPT-3 is.
And then GPT-3 is, if you're going to build something on top of GPT-3 and even use GPT-3 to ask open-ended questions and so on, for a specific application, it's very difficult to guarantee the results, right? How do you evaluate that? How do you ensure what gets out? It's super tricky to use. It's a super cool demo, though.
It is a super cool thing from an AGI point of view.
Yes,
it is. It's super cool. So we shouldn't value the thing.
No,
but they shouldn't mistake it for being of commercial business use.
So narrow AI is easy. You can go much shorter the distance to commercial value to do something which is very, very useful in a narrow space, of course.
And quite often, you might get upset with me for saying this, Anders, I don't know, but it's quite often it's better to go quite a lot narrow as long as you get the results that you need, because you might end up with something more robust, simpler to manage and stuff like that.
I don't get angry, and I think you should even go to like XGBoost and random forests.
Yes.
Don't worry about it. Don't be
very, very good, because that stuff usually works.
Yes. Don't be a snob. Don't be a snob, right?
Be super pragmatic of what you need, and if you need a mean accuracy of 80% or something like that, and you reach that with something super simple, just stop. It's fine.
Yeah.
You don't need to build anything else.
I just had another idiotic question. Trillions of parameters. What type of machine are we talking about?
It's not a single. It's thousands and thousands of machines.
Are we talking
working together?
That's a lot of machines.
Yes.
So could you imagine? Well, what is it? Is it like thousands of normal servers, GPUs? Or what is it? GPUs,
probably GPUs, because it's not. I mean, some companies are starting to use more and more, like Google TPUs, and I think Amazon are developing something in that direction, right?
And what is a TPU compared to the GPU?
It's very similar. So GPU is very, very good at doing parallel processing of math, so that you have lots of different numbers, data, and it's very good at doing additions on lots of those, or multiplications on lots of those at the same time. But you can structure that kind of processor in a slightly different way, like Google has done with the TPUs and stuff. But it's basically the same thing.
TPU is a subset of GPU. Could you argue for
it's more specialized? I mean, it only works for very, very specific operations that is specifically useful for deep learning. GPU is actually a bit more general, and then CPU is super general.
Super general, but not as fast in this kind of very, very. It's a particular kind of computation that you do for it, especially for neural networks, basically.
And what does T stand for?
Tensor processing units.
Tensor.
And it's arrays.
It's arrays of GPU.
You're processing arrays, not necessarily tensors. This is a sort of pet peeve, but it's
And Elon Musk, of course, has his own chip now. So he has the FSD thing, full self-driving chip.
Yeah.
Now, you lost me. What do you mean with chip? What are we talking about?
So he threw out in Teslas before, they have NVIDIA GPUs, and they threw it out and developed their own chip. Instead of the GPU.
But I saw one of those. He got one of the brainiest chip guys in the world to work for him. He came in like 2 or 3 years ago. I saw YouTube is beautiful, right? But it was like they were talking about building the AI chip for automotive ground up. Is that a TPU now, or is it something else?
In Tesla? Or?
Yeah.
They have their own chip. It's not a TPU is the Google thing.
But Tesla has a proprietary chip.
Yeah, FSD chip.
FSD, right? That's the
chip. Yeah.
What's it?
Full self-driving.
So it's autonomous. Yeah.
It's for specifically full self-driving
so
purposes.
It's tuned concretely for the data problem of self-driving cars.
Yeah. But Elon does everything with the first principle mindset. So he just threw everything out and does it himself.
Yeah, there are other companies like doing similar stuff for
FSD,
cars.
So when we hear about FSD, well, that's the Tesla version.
Yeah, for the chip. But
is he selling it to someone else?
No, I don't think so. I don't know. I don't think so.
I have no idea. I don't know. It's I guess it's nowadays a very super cool competitive advantage. I don't think Apple's are going to sell their super efficient M1 chips to anyone else, right? It's probably not.
Yeah.
And it's probably the same with the TPUs and the Amazon stuff and all of that.
But Apple has already quite a long time done their own chipsets, right?
Not processors at this scale.
They moved to Intel for some time.
They moved to Intel, but then they've been bragging about their own chipset, I think, the last couple of years, right? Anyway,
Apple crapware thing. I actually have an Apple phone. So I shouldn't say
show your phone to everybody.
We've had this Apple versus
Okay, let's go to more serious topics, I think.
Yeah.
Yes.
And we've been speaking quite a lot about federated learning and decentralized AI and things like that. And I may go a bit against you now, Daniel, but please try to describe a bit, what's the potential with federated or more generally decentralized AI?
I think right now, at least, the most urgent need is basically that it's difficult to get all necessary data in one point. and it's for legal reasons, it's partly for transport reasons and things like that, but that's, I think, the main driver at the moment, basically. And are we going to end up in a situation where everything is federated learning and distributed algorithms and decentralized AI and stuff like that? No, probably not. But I think it's probably going to be quite a bit of a core component of a lot of stuff that at least larger enterprise companies build and do, basically. If you're operating in lots of legal systems, if you're operating in lots of devices, if you're building lots of base stations or something.
And I guess it's easy to describe, like Scania, for example, and they have, the trucks, and of course they can't send all the data, to a central location and need
so
to.
It's
And I guess that's a potential good example of why you potentially need
exactly. You could use it, Yeah, absolutely.
Both from a bandwidth point of view, you don't want to send all the data all the time, and also from a privacy point of view, potentially.
Although we should be clear that it doesn't solve all the potential privacy problems necessarily. So
because I may stab down now on this screen. Okay,
Sorry?
Yes, but you can easily understand it's.
You can understand the drivers. Yeah. You can understand the drivers for it, basically. Yeah. And it's
drivers from a
point of view. but I've been in 2 different industries now.
Yep.
I'm having the fortune of being what I think is being part of a paradigm shift.
Mm-hmm.
First, in the energy industry, where you go from a very linear value chain from production, to trading, to networks, all this. And we talked about the 3 fundamental Ds: decentralization, decarbonization, digitalization.
Right.
And essentially, the paradigm is that the
digitalization.
What? Digitalization. That's our favorite discussion.
We just have this kind of argument all the time. Digitalization versus digitization.
Yeah, let's
go there.
Yeah,
let's go analog.
But
I think that's
but the core topic is that when you look at the future energy system, because of renewables and because we become prosumers, you're essentially discussing a networked ecosystem. Yeah. So the energy value chain, linear, becomes an ecosystem.
Yeah.
Now I've been in Scania. Scania is understanding one of the core topics, how to reposition yourself from a truck manufacturer to what is your position in a transport ecosystem.
Right.
Are we going to sell trucks in the future? Are we going to sell transport optimization?
Yeah.
Autonomous vehicles, electrification, and then a shitload of data and AI to optimize the whole system, right?
Yeah.
So all of a sudden now, you are not in a proprietary system where you are in control anymore.
No.
You are a participant in an ecosystem. And for that ecosystem to be optimized, algorithms needs to look at things holistically. And you need to then go back to the core topic, what is your core IP?
Yeah.
And was it general purpose? In energy, I think this is the best example to understand. I had this data problem when I was, we have what is called network data, right?
Yep.
And basically it is NSI classed information, national security information. I have two tables in the same system. This table I have to share with the regulator.
Right.
This table is private. GDPR.
Yeah.
So basically, the way we have built systems, and we have tried to class the system: should it be shareable data, or should it be locked down data? Nuclear power plants, all the way down to, terminal server data.
Yeah.
We have a fundamental shift in application centric to data centric, and from data centric, distributed data centric.
Yeah.
And I think I don't think there's a turning back on that. So edge intelligence versus central intelligence, or whatever you want to call it, and that is one core use case. But the ecosystem as such, I can define it in fintech, finance. I can define it in water, intelligent water. I can define it in sustainable cities. I can define it in networks. I can define it, in transport and energy. So very fundamental big industries that needs to go in this direction. And by the way, I think the health and public sector has the same problem.
Yeah.
So I think distributed, whether we like it or not, is part of the core.
But distributed is different from decentralized, I would argue.
Yeah, this is interesting because...
And it's great that we as computer scientists don't really have clear definitions of what these things mean. So we
That's
can argue
exactly
about
right.
them. We can argue about them constantly.
Was I talking about decentralized or distributed?
Yeah.
In your opinion, because I don't really know how to use those two words, to be honest.
Yeah. Well, yeah. I speak too much today, I think, but it's just because it's so interesting topics. But we've spoken about this before, decentralized versus distributed. So at least in the machine learning point of view, distributed means basically you distribute the training in different machines, and decentralized you actually move the model to where the data is instead.
So on a technical point of view, you can make this distinction quite clear. Because if I move away from the machine learning part and then I move into cloud computing, and we talk about the data mesh. Have you heard about the concepts of this?
But okay, let's try to close, because I think we're going a bit down the rabbit hole.
I'm just trying to say that distributed and decentralized is used differently depending on which field you're in.
Yeah, sure. They are.
But in distributed, you usually centralize the data first and then you distribute. In decentralized, you never centralize. You just train it in each client instead. So it's a big difference from a machine learning. But the point I was trying to make, of course, I agree. We've been working, and I've been working with Federated Learning for a long time, with AI Sweden, and both in Medbert and the Federated Learning project and so forth.
And it's been up on the radar, and I've been working with Ericsson with this kind of topics for a huge amount of time. Basically, it's just that now it's much higher on the agenda. Basically,
my potential argument here is that there is a middle point between centralized and decentralized. And what I mean with that, if you take, for example, medical use case, Folktandvården or hospitals, Region Halland, and the different regions we have, they usually can, if you take the pure decentralized learning, it's like the tracks, for example. They are clear, very easy to understand problem. They can't send the data, they need to do it in a decentralized way, and with mobile phones, of course, you don't want, from a bandwidth point of view, and certainly not from a privacy point of view, to send all the data you're typing in on the keyboard. It's very easy to understand, and you need to have proper federated learning in place to make that work. But I would argue, and I would like to hear what you think about this, Daniel, that so many other use cases actually can have some kind of compromise between the two. And if you take Folktandvården, for example, they have no problem to move the data, extract the data, move it to a central location inside the organization, and then train and work with the data centrally inside the organization. And that, I would argue, is not federated learning.
No, not necessarily, no.
And it seems sometimes that it becomes a bit of hype, actually.
Sure, of
where
course.
You say that everyone should use federated learning, or not you necessarily, but the rest of the world.
And trust me, I'm not going to say that everyone should use federated learning, because if it's possible to centralize data, you shouldn't use federated learning. That's basically it, right? It's it's much easier to actually, if you can, and it's cost efficient, and you don't break any sort of difficult integrity issues or legal issues or something like that. It's always easier to have everything at one place and make everything work, right? It's so much easier.
Both from an orchestration point of view, but also from a training performance point of view.
Exactly. You're going to get better results, basically.
And easier to
way easier.
Good. Okay. But now I'm happy.
Yes. But I think this question is super interesting, right? Because where are the interesting middle grounds, and how do you build them, and how do you orchestrate them in really, really complex scenarios and stuff like that? That's super interesting, actually. And and if we're talking about integrity challenges and so on, so how much can you centralize before it becomes a problem and stuff like that, basically.
But here I think we can go to Scania, and I think the master of all masters, when we talk about the edge, the vertical the data value chain from the edge to central, I think it's still Tesla, right?
Right.
So they have built the most insane data stack from the car. How they collect so much sensor data. But then, of course, they are sending all that down data centrally to tune the model, to improve the model.
Not all. They have a really smart way to select the data.
But what they have done here, I think, is because in Scania, of course, we talk about over-the-air updates, and it's complex.
Yeah.
It is difficult to do well.
Yeah, but I think you have a point here. If you're working with, for example, non-integrity sensitive data and things like that, sensor data or something like that, should you do all learning at the edge or federated learning and so on? No, there might be a better way. There might be a better way of collecting something, build a model, distribute that,
and then send the model back,
and do some kind of variance. I don't know. Variants of active learning and so on, and letting the models locally say that this looks like a unsure data point, I'll send this back, and stuff like that. There are so many other approaches that you can use to actually reduce the number of data points you need to send and so on.
Edge active learning, that should be the AI Sweden, I think.
Yeah.
That would be awesome, I think.
Yeah, but there is actually a reason that we called it decentralized and so on, not federated, because we didn't want it to become just federated learning.
Awesome.
We need to include all of these approaches, basically. Otherwise, we're locking ourselves into something that might not really work for everyone.
And you're nailing it, because you're basically clarifying we need to explore several different core scenarios here.
Yeah.
And there are several of them, but maybe we can find generic design patterns that are more suitable for different ones. And that is a huge step forward for something that is blurry today.
Yeah, and it's sort of also interesting and kind of fun that there's never going to be just one way of doing things, right? And it's for different applications, we're going to have different kinds of solutions, but we're going to have design patterns, better methods, and stuff like that. But of course, when you're moving towards, for example, federated learning and things like that, it's quite, we're getting a little bit used to having decently mature tools in TensorFlow and PyTorch and stuff like that, and all of sort of. They're getting better. But you're sort of taking a step back when you're getting into the federated space and stuff like that, and all of a sudden it feels like taking 5 or 10 years, step back in terms of framework and tool maturity and stuff.
But what we have realized when we discuss things about IoT or edge intelligence, there's been a lot of focus on IoT to collect data, and it goes one way, and then we do something, then we can have insights here. But I think what is really the explosion with 5G and having edge intelligence is that you're collecting data maybe to find a model, but then in the end you want the data back in order to steer or upgrade, send out the next patch, over the air. And I think over the air type thinking is everywhere with 5G. It's in the smart manufacturing setup. And the holy grail is not to send data centrally. The holy grail is to really steer it and improve the whole system. You can basically upgrade the machinery you have. Like the Teslas, they get upgraded all the time. That will happen to tooling and machinery in the factory as well. I promise.
Cool. We only have 10 minutes left.
Yep.
And I'd like to move to more societal, long-term, philosophical kind of topics.
Right.
And please fill in. But let me start with something. And we're both from a more academic, research background point of view. And I'm personally a bit concerned with the recent progress, especially in academic AI research.
Yeah.
For one, the one concern potentially is the tech giants is just moving so fast ahead that the normal universities is not keeping up.
Yeah.
The second thing is that the whole, publishing to journals and conferences is also being potentially superseded by just doing preprints to archive.
Yes.
Would you agree with this, or what's your thinking about,
No.
what will happen in coming years when it comes to AI research and perhaps in general research?
Yeah, I think, this is a super good point, and it's sort of something that I would say we're all struggling with this right now, right? There is so much, and part of it is scale, I guess, because right now, compared to just 15 years ago or something like that within these fields, the output is just so much immensely bigger. So it's so much more difficult to follow and so on. And some of these conferences and so on that we used to go to have grown massively, basically. So it's very difficult to keep track of where everything is. And there is a little bit of this publishing on archive, which I think is a good idea to start with. Distributing your results and so on. But there is a little bit of this, we did this first, let's get this out here. And just, not necessarily with...
What's the peer?
Yeah, there's not necessarily peer review, but perhaps that's not necessarily the main problem sometimes, but it's the rigor, it's the mission, it's the scope of what you put out, basically. How well thought out are these things? It's, we had tons and tons of papers, but I would like to have more of, I don't know, Shannon's 1948 paper on information theory or something like that. He took some time to write that, but it's very consistent, it's coherent, it's a big result, it's very worked through, so to speak.
And now were you spitting out?
It's also like these kind of, universities have these kind of strong goals, and you have to publish these papers.
Yeah, exactly.
When you have these kind of conferences, they actually try to find these conglomerates or this kind of weird, if you review my paper, I review yours and approve it, and they like set up these kind of rings where
cartel,
you can...
it's called?
Yeah, cartels, more or less, I guess.
It is, it's a little bit, and I mean, part of the system is gaming the system, right? So if you can...
Gaming the system.
So if you can, for example, build your academic reputation by, if you sort of create part of your own field and your community, and you review and publish and, together. Yeah. Of course, it's super. I mean,
the academic cartels. You heard it here first.
No, it's not first.
I'm joking.
Yeah. No, but and it's
What do you think it done more long term? I mean, will this improve? Will we change the way we do academic research? Because I guess we still need it. I mean, it would be.
We definitely need it.
Right?
But I don't know. I think we need to do a few more things, basically, on a very basic level from academia as well. And that's basically, at least from parts of Swedish perspective and so on, broaden the notion of academic impact beyond papers. I mean,
right.
Why shouldn't if you write something, open source code that's used everywhere in the world, why shouldn't that count against your?
So not having just a paper, but also a data set, or
a data set or a code and stuff like that.
Yeah.
And sort of people are sort of trying to fix it today that if you publish a data set, you write a paper about it that you can get citations from and so on.
So
but the whole thing gets a little bit,
So maybe there's a redirection of focus and attention and importance and value to actually the useful result, which is the data set. Sometimes even,
sometimes the data set, sometimes the code, sometimes the benchmark, and sort of you typically use a sort of paper proxy and stuff like that for these things to get something to count. But it's, I think.
Have we narrowed down too far that it's only the paper and the published paper that counts? Have we taken that too far?
Yeah, potentially. I mean, there was a big. If you know this Siraj person on YouTube. Have you heard about Siraj?
No, I don't think so.
He was really big in YouTube and did a lot of machine learning podcasts and videos. And now, just in recent weeks, he basically plagiarized 2 papers and published it. And he only changed, some few words. It was so easy to detect it was plagiarized.
Yeah.
He did like search and replace on. He had some terms like logical gates and things like that.
Right.
So he changed gate to door. So it was logical doors. And it made no sense at all. Jesus Christ. And it completely destroys his credibility. But it's because it's the pressure of being able to publish and you do whatever you can to just make it work. And it's sad.
Yeah, and there are definitely... we talked about reproducibility earlier and stuff like that, and of course, I mean, there's a large push on actually having very good results and state-of-the-art results. So you do what you need to do to get those to get published and things like that. But then it might again be difficult to reproduce it, and I don't know. Sometimes I feel like this push for state-of-the-art results, having the bold-faced number in a table, is taking it's taking things a little bit too far, because it's it might not be super interesting. Yeah, you pushed the boundary a little bit in these numbers that might not actually mean all that much.
We've had this conversation so much, and it's a little bit like, what is the usefulness of pushing a benchmark versus coming up with something novel? But it's a little bit like the whole industry, the whole machinery is set in a certain way now. So if you want to game the machine, that's what you do.
Yeah, to a large degree, I think that's true, actually. So that's
Okay, but what are the underlying symptoms and root causes what should we work on to make this more useful? What could we? Is it easy to pinpoint? I'm not sure it's so easy to pinpoint what to. But it's a systemic approach.
Yeah, it's sort of a systemic issue. So how do you fix it? Basically, it's not super easy, and it's not. We don't need to fix everything, but some things are not working as well as they should by now.
But if we want to parameter tune this, which parameters do we want to tune?
I don't know. Basically,
I certainly have no idea either.
I don't know. Something that could be tuned is basically the incentive structure, I guess, for researchers.
The metrics is usually a good idea to start with.
It's a Jeremy Howard thing, getting funding, and Jeremy Howard, is the president of previous Kaggle and now Fast AI, and he basically said, this quote of most research in deep learning is a complete waste of time.
Yeah, you love to say that.
And I don't disagree necessarily.
But it's basically, he's referring to what you just said. Yeah. Just pushing 0.1 percentage point on some data sets. And there are so many other research questions you should focus on to really make use of data, to make it actually of beneficial value for society in some way or for companies.
Yes.
But it's a systemic problem why this is getting published and this is not getting published.
Yeah, to a degree, and basically it comes down to incentives and why do people publish and things like that.
And I read a funny, like a Medium article, which is basically the headline is, if Einstein would have published his theory today, he would never been published because it doesn't fit the mold. Did you see that? I think there was a quite interesting argument in this whole debate. That the way he had a prose, he had a story, he had something else, right? But it doesn't at all fit into the gamification of being published.
No, but I think that's part of the also part of, again, lots of different areas of research have quite different ways of expressing themselves and how you formulate things and stuff like that. So it looks quite different in different areas, but it's a matter of efficiency right now. When you read a paper within machine learning and so on, it's structured in exactly the same way as every other paper. There's no, at least not much flowery language and stuff like that. It's very to the point and.
Is that good, or do we miss?
It's very efficient.
Efficient.
It's efficient. It's efficient when you read the papers. It's efficient when you review the papers. It's partly efficient when you're writing the papers and so on, because everyone works to format, right?
Yeah, you template.
Yeah. So and that's also, it's efficiency.
And we just have a few minutes here, but I think we potentially could end a bit like we started, which was a bit about the pandemic, about the restart or rebooting funding that we can get and these kind of things. And I think you said a number of really interesting stuff there. And thinking about that, we have the pandemic and it's had a user effect on society at large, economical impact, for so many companies. And now EU potentially is putting out a lot of funding.
Yeah, this restarts funding and things like that.
Can you just describe that a bit, what is happening right now and what potentially is concern with that?
Right, so I'm not an expert in this area at all, basically, but there is restart funding coming from EU to reboot the economies, I guess, in member states and so on. I think there's at least partly a goal of making sure that this can drive transformation of industries and towards digitalization. Is that the goal,
or is it just rebooting in the way we did it before?
I think that some of the goals are to actually drive transformation, which I think is interesting. Yeah, and again, I'm not an expert on this area, but I think it's at least interesting. But in any case, I think we should definitely try to see these funds now as a way of driving transformation, right? Because now we actually have some funding and things like that, investments, and this is happening in companies too when they're rebooting their business and so on. There's all of a sudden a feeling, at least from the outside sometimes, that there's a lot of money in the system at the moment. So let's use that to drive these AI transformation, for example, and to bet on a little bit more forward-looking technologies and methods and so on. I think that we have the chance now. The risk is not huge. Something good will come out of it, basically. So let's push for that. So I really would like this Sweden to really, push for something really transformative, push for AI, push for quantum computing if you like. It's not my thing, but push for something.
To destroy it, that I'm saying that.
Yeah.
But
Sorry?
No.
But is it the same for all the countries in EU, or it's mostly from Sweden?
Where the money is spent, or
No, so the EU is providing probably the same funding across, is distributing the funding across the countries, right?
Yeah.
So when we are discussing about the small percentage given to AI, are we discussing only the Swedish?
Now we're talking about. I only have any insight into the Swedish system, and
But the topic is a little bit like when you're putting a reboot money on the table, where can we channel it that makes a good impact?
Yeah. And it would be I think it would be fun and interesting and the right timing to put it towards AI and so on. When we're a little bit behind in AI investments in Sweden and so on, can we use this now to actually put this?
So should we even condition the money on saying that you should transform it in some way? Or
I think that would be nice. I think it would be nice to have some larger initiatives around specifically AI and specific technologies and things like that to actually push us a little bit further and push us to actually invest in these things specifically, because there has been a little bit of a lack of investment in Sweden in this area.
But I that triggers me. We did at early stage of the pandemic. Goran put together a roundtable with experts around viewing the core question was, is the corona or COVID a black swan event? And actually, can you come out ahead of the game? So the whole conversation was a little bit like, could we have predicted it? And actually now we are seeing things breaking that is clear what we need to fix. So we now have a more even clearer view of how we need to build resilient systems, as an example. Yeah. And then we are highlighted that, well, actually, we could name example after example of how things truly accelerated when you had a common goal and a common, purpose.
Absolutely.
With the vaccine. And I could drive examples from Scania, like we call it the golden arrow in Scania, that basically when we needed to get data, we needed to get understanding of something from the top management. We had a golden arrow, we call it. Golden arrow. It's a known, and it means drop, fix. And we had tremendous speed and fantastic results in terms of getting to what insight or data or what we needed to do in order to better understand what is happening to production, what is happening to supply, stuff like this, right? But it proved clearly the speed we can move with was tremendous when you work in a different way.
Yeah.
So I think this type of funding is not only about then. I would be sad if it goes all into broadband, or something very infrastructure,
or something very basic. Yeah.
So we had a discussion about this last week on a podcast, right? And the question is actually, did organizations, industries, and countries learn something?
Exactly.
Are did they just basically adopt it? And now, because it seems like it's going to go away, they going
back.
Or actually they started changing. So did they adopt it
or learn
or changed? Changed is a very important thing, because
and unfortunately less change than we think.
And this basically what you are mentioning right now is just eye-opening that we are going back to the old roots. And that is very discouraging, especially after making a very big framework about AI, where they say, the whole thing was to show that we have AI, we look at it and it's good and we want to invest in it. So that was the positive thing of the entire framework. And now to go back and not dedicate money to AI, and instead of that going to the digitalization or infrastructure, we don't need that. Sweden is already the most digitalized country in the world. We need AI.
No, but I need to come back to what you said before the podcast started, which I thought was brilliant. The reason why we should now make this transformative investment with an AI-first mindset is simply because it drives the core business questions first, and based on what, because the AI is closer to what optimization we want, and then we realize what infrastructure we need in order to fuel that. So the problem when you pour money into pure infrastructure, there is no direction in the same way what to use it for.
Yeah.
So simply by having an AI first mindset, you channel the infrastructure investment in a better way.
Exactly.
I thought that was profound.
You provide purpose and direction.
Purpose and direction comes from the AI question,
Exactly.
not from the infrastructure question.
Yes. Exactly.
So I have a question, and I think it's a good closing question before we go with this. So what can we do to change the politicians and EU and everybody else to look at it? Because the industry is ready. You obviously
the industry is ready.
You're ready.
We are ready.
The research is ready. So what can we do for them to change their mind? Because obviously some countries are already running fast, and we are just looking at how time passed by.
Yeah, I think...
what can we do?
If I can speculate just a little bit, I think a part of it is actually to realize that from politics and from broader citizens and so on, is that AI and automation and these things, these are not necessarily technical questions on a societal level. And just saying that, we're going to invest in AI and so on, everyone can do that. But in the end, when we decide how and when to use these tools, what do we automate, with what purpose, with what target, and so on, then it essentially becomes politics, right? How do we prioritize and so on? It's not like we're trying to build something actually completely necessarily different in many instances and so on. We have lots of bureaucratic processes and things like that we have built based on political decisions, principles, and things like that. These are getting back to us now when we're building larger AI systems. What are we going to use them for? How are they going to make their decisions? How are they going to prioritize and things like that? Who gets healthcare? Who does not get healthcare in an automated system? This is a political decision, not a...
It is.
But should you really say automate then? I mean,
It's a defining
perhaps it could
decision.
be, what should we really augment humans to do?
Yeah,
as well,
exactly.
right?
And it's, and what should it help humans provide and things like that? Because it doesn't matter if it's, again, if you go back to a very old quote, basically, it doesn't necessarily matter if it's a machine of flesh and blood that makes decisions and so on based on the wrong principles, or if it's
calling humans machines.
Yeah, but I'm calling a bureaucracy machine.
Yeah.
Yes.
A bit.
Because it's sort of a manual machine, right?
Oh yes, it is.
And it's operating based on certain principles and things like that.
And it's a machine sometimes without an owner.
Yeah, exactly. And it's sort of, I think we have a chance now when we're actually going to put AI to help us make decisions, to help prioritize resources and things like that. Because now we're actually going to have to be very explicit about what we call cost functions and things like that. What is it that we're actually optimizing?
This is what I like.
It's not vague anymore. You have to be pretty darn specific when you build these systems.
Narrow
sometimes.
AI needs specific problems to solve,
yes.
and then it forces you to articulate your question.
Exactly.
Awesome. To try to end this topic in a bit of a positive way. I think we potentially have, but still.
This was very positive.
This was positive.
Yeah. We were talking about how to change things.
We were talking about how to spend billions. I love it.
Yeah.
Now you're interrupting me. But okay. To try to close this topic in a positive way, perhaps we could, as you say, make use of this restart funding or reboot funding in a way so we potentially could come out of the pandemic in an even more positive way than we actually came into it.
Exactly.
Do you think so?
Yeah, I think so. And it's not necessarily, compared to other investments and so on, not a huge investment. Yeah. I mean, it's relatively small and it's going to pay off. And we really need to make it. Yeah.
Pay off both economically but also societal point of view, medical point of view, and so many things.
Exactly.
Yeah. We just need to convince politicians and other decision makers to
to put $1 billion crowns or something like that this direction. Absolutely.
Awesome, Daniel. What's next in your life? What's happening coming months, personally, privately, professionally?
Oh yeah, all of these things that we've been talking about, building AI Sweden and so on, I'm super interested in. I'm super interested in developing some of these research topics and things like that further. But in all honesty, I'm really looking forward to after a couple of more shots in the family of flu vaccine and so on, to be able to actually travel to family in Portugal and things like that. That it's this. Apart from everything else, big scale, small scale that we're doing, I want to travel. I want to travel and I want to see family again.
Sounds
good, awesome.
Do you have any potential recommendations? Who would you like us to put on the podcast that you would like to listen to?
Oh, that's a very good question. I haven't thought about that. Yeah. Who should we put on the podcast? Yeah, I guess you've had quite a few number of researchers and things like that.
Some politician, maybe.
That's what I was thinking. Shouldn't we put a politician here?
I would love to have a politician here.
Help us. Yes.
Yes. So,
but the relevant politicians.
Yes, and someone who is interested and so on. Yeah.
That would be fantastic.
Yes. So, of course, perhaps Ibrahim Baylan or someone like that. Mikael Damberg, who was the Minister of Industry before, he, at least when I met him and so on, he was super interested and very, very eager to know more and do more and so on. So a politician could be fun, right?
Baylan and Damberg.
Baylan and Damberg, and perhaps Anders Ygeman from infrastructure.
I would like to have somebody from economic standpoint as well, because I believe in order for people to listen, we need to show them the numbers.
Could
the economics of AI.
Yeah.
The impact. Good.
Perfect.
Yeah.
That sounds like great suggestions. I think we should aim for that, but that will be after the summer then.
Yes.
Now we're taking a long summer break.
But of course that means we will not rest. We will plan.
Yes.
To make this more awesome coming back.
Daniel, always a pleasure to speak with you.
Likewise.
You are so knowledgeable and I think communicative, and being able to describe very complicated things in an easy to understand way, which is so important.
Even parameters.
Thank you.
And I wish you the very best with AI Sweden, such an important initiative, and you've already done so awesome work there, and just keep up the good work.
Keep up the good work.
Thank you so much.
Yeah. Keep up the good work.
Thanks for having me. It was great fun.